and you expect a response back. Another method is message exchange patterns. And a message exchange pattern is, well, when I use it at work, I use primarily AMQP. And what I do with that is I publish a serialized JSON payload into a queue, and then I will have another application which will consume from that queue. And that consumer or application will literally just do a certain job, say like sending an email to a user after they've registered. I'll show an example of how I kind of do that, but I'm doing it without RPC rather than AMQP, but it's all kind of the same thing, really. So to start with something familiar, I wanted to start with HTTP. And I'm embarrassed to say, as a developer, I've never actually looked into how HTTP actually works and what it actually looks like. As a developer, I've always worked in an agency, and I've always just been expected to deploy something, and I've never really cared what I'm actually using. If I asked any developer in this room to develop an API, you're more than likely, well, 10 out of 10 times, you're going to be using HTTP. I don't have to specify that. You'll probably just do that out of the box, well, by yourself, come to that assumption that that's what you're going to use. So I wanted to make this talk a bit, because I thought it was going to be a bit boring, so I was going to make it a bit fun, but obviously I got told off for it, so you're going to have to use your imagination with the logo. I wanted to make a request to GitHub, and I wanted to just make a simple HTTP request to GitHub for a URI with something juicy. It's just a GET request, and as you can see from the top, 4 lines, that is my request headers. There's no body in there, so there's a space between those top 4, and then the second set of 3 lines, and that would be my response headers. And you can see in there that I have a response header of 301, and obviously, does anyone know what 301 status code is with HTTP? It's permanently moved, so it's a different location. So you see here I've also got a response header of location, and I'm given a HTTPS location instead of HTTP. So in my second example, which is a bit small, you can see I'm doing a request to that HTTPS endpoint, and my response headers are a bit different. You can see, like, in the second block down below, the top bit there, the status code is different. It's a 404. The page doesn't exist. And using HTTP is really nice because it's a universal sort of status code. So whenever a server says 404 status, the web browser instantly knows that that page doesn't exist. Not only that, you can see at the bottom here, so you have all these response headers, and then there's another space. And at the bottom, you can see it just says, there's just some text that says not found. And that would be my body of my response. And if you see in my request headers, I haven't specified a content type. So if I was to specify a content type of application HTML, I would get HTML back rather than plain text. If you find the response header for content type, you will find there's one, it just says text plain. Most likely, I can't really see it on my screen, it's really tiny. So looking at this slide, HTTP is actually an application protocol. Usually, like if you're using PHP, you're going to require an application in order to interpret the actual protocol. And that application would normally be Nginx or Apache. So your script that you're writing in PHP would sit in the application layer, but it would require a second application in order to call your script with whatever HTTP information that you have. You can also see here that I've mentioned that HTTP is a synchronous request-response pattern protocol. So that means whenever we make a request to anything, we're going to open a TCP connection. I will touch on TCP a bit later. You can also see in this sort of diagram that I've got application, TCP, IP, and hardware on the left, and the same on the right. And whenever we make a request from, let's say, our web browser, we're going to go from our application